Hello, this is Jeremy, and today Tomas, Sean, and myself will be talking to you about how to use the LiCor for soil respiration measurements. So we'll begin with cellular respiration. This is a concept that most of us should be familiar with by now. The formula for soil respiration is taking 6 sugars that are stored in the organism combined with 6 oxygen, and those yield 6 carbon dioxide, which are released to the atmosphere, and 6 water that are released as well. And then the 1 ATP, which can be used by the organism for energy. Now, it's important that we measure soil respiration because it indicates the amount of biological activity in a system. And using this, we can infer whether the soil needs more soil organic matter, whether the soil is efficiently mineralizing nutrients for plant uptake, whether the microbes can store nutrients, and whether they improve soil structure. Now that we've reviewed soil respiration, I'm going to talk a little bit about the LiCor products that have evolved into being able to measure soil respiration. So the products that this company makes were originally geared towards plant measurements, and it wasn't until later that they started incorporating other types of measurements. So in 1971, they designed the LI-185 Quantum, and it's a combination of a radiometer and a photometer. Prior to this, light was measured using foot candle meters, and this type of measurement is in reference to what the human eye sees. However, with this system, the light is defined in terms of photons, which is a more useful metric. Then in the 1980s, they developed the LiCor 6000, which is a portable photosynthesis system, and this was one of the first of those portable systems. And it did not have a sufficient infrared gas analyzer, so the company decided to make their own. That system, the infrared gas analyzer, was well received, and so they actually created the first standalone CO2 analyzers. And that's these products here, the LI 6262, 6251, and 6252. After this, they developed the LI 6400, which is another portable photosynthesis system. But this one, however, was designed to use novel accessories to measure additional parameters. And the latest iteration is the LI 6800, which is the latest model, and it measures gas exchange and fluorescence primarily. And it's nifty because it has a touch screen, and you can also program calibrations so that you don't have to manually change every metric for this system. And lastly, we have the soil CO2 flux chamber, which Tomas is going to talk to y'all about in the next slide.
Hello, my name is Tomas Dwarka. I'm going to be talking a little bit about some of the materials used by LiCor for soil respiration monitoring. The first material we're going to look at is the LI-8100A soil gas flux system and the LI-8150 multiplexer. So the gas flux system is actually the reader. So that's the thing that has the turquoise PVC pipe looking attachment. And the multiplexer is the yellow briefcase looking object. And these two objects work best in synchrony. You can use multiple gas flux systems and plug them into one multiplexer. And we'll talk a little bit more about that in the next slide. But the next material I want to talk about is the LI6800 photosynthesis system. So, like the gas flux system, it is used to measure CO2 levels. And on this picture right here, you can see I have a lot of the parts on it diagrammed out. And some important things to pay attention to here are the chamber bowl. So that's the chamber right there that actually connects to soil collars. And then there's a pressure vent near the top. That is to release pressure that builds up in there, so CO2 gases coming out of the soil. And then there is an air inlet valve, which is used to let air in, and then there is an air outlet valve, which is used to flush air. So we'll move on to the next slide now, talking a little bit about the procedures. So now we're going to look at the procedures, basically a little bit more of how these machines actually work and what they do. So the LI6800 photosynthesis system. This machine measures changes in CO2 when closed over the soil. So soil scientists will put a soil collar in the ground, which is essentially a PVC tube or a metal pipe, and that is sticking a couple inches above the soil, and the photosynthesis system will attach to this PVC pipe, aka the soil collar, and it will use the technology on itself to basically release the CO2 in there, so it will have a fresh reading of CO2 leaving the soil. And it's used oftentimes with a Stevens hydroprobe, which is like a secondary attachment, with 3-pronged secondary attachment that sticks into the soil, and it monitors temperature, salinity, and as well as the moisture content, just to give you a better idea of the soil in an area aside from the respiration. And this data is logged into a device and a computer software, so you can further analyze this data and do anything you need to do with it. The next machine, the LI8100A soil gas flux system and its unison LI8150 multiplexer. Just like the photosynthesis system, these are used to measure CO2 flux in soil. However, this is a modular system, and it allows for long-term measurement or large span measuring, because you can connect multiple gas flux systems to the multiplexer. So this multiplexer is a reader and an adapter. So by plugging in these different gas flux systems, you can essentially look at the respiration level in an area, in 16 different areas actually, and it allows you to increase your sampling size and get a better idea of how the soil is actually behaving in an area. And it also has innovative chamber designs made to not confound measurements. So in the past, many machines have been made with lots of errors in how they connect to soil collars, or they are oftentimes heavily affected by outside elements like the wind or rain. New machines like the soil gas flux system have advanced technology that gets rid of these errors and allows for great measurements.
Hello, my name is Sean, and I'll begin talking about the advantages of using the LiCor soil respiration system. The first major advantage of the LiCor is its flexibility and convenience. LiCor provides real-time on-site readings. This is achieved by connecting the LiCor chamber to an analyzer, which allows the user to get real-time flux readings for CO2 and methane readings. Survey systems for LiCor allow users to take samples from many different locations. The compact design of LiCor is easy to move around and makes getting to hard places simpler. Being able to move the device to different locations along testing sites allows users to cover a wide range of area where long-term sampling is not feasible. The long-lasting battery provides up to 34 hours of field time use, and you can manage all your data with the free software SoilFlux Pro included with the LiCor device. With this software, the user can compute statistics on data collected, view and revise soil flux data as well, and also create a KML file, which can be used to create a map and upload it to Google Earth to create a 3D map file of the area sampled. The next advantage of the LiCor system is the high precision results. Artificial soil disturbance is said to have a major impact on soil readings. The LiCor has an automated mechanism that seals the chamber with a rubber gasket to minimize soil disturbance. Mixing of air inside the chamber is an important component for getting accurate flux measurements. The LiCor does not use motors to achieve this like other companies do. Instead, inlet valves are used to ensure consistent and accurate air mixing. Lastly, pressure vents in LiCor chambers achieve an equalized gas chamber. Unequalized gas chambers are said to lead to overestimation in flux readings. I want to mention that there are some disadvantages to using the LiCor system, however. One disadvantage, as mentioned in a 2002 research article studying biases in chamber-based soil respiration measurements, is the small chamber of the LiCor systems. The chambers are 72 square centimeters, and the article states that longer chambers can easily be made by simply using PVC. The article found that using the larger chambers, typically around 300 to 700 square centimeters, still produce results for coefficient variability similar to the full population mean they were testing. The next disadvantage is that there are used typically less chambers when using automated chambers. The LiCor can accommodate 16 chambers, but the expense of managing 16 chambers is not likely realistic for any scientific scenario. In conclusion, while the LiCor products are extremely useful, they may not be suitable for this course because they are quite expensive. It costs about $50,000 for the photo system, which does not include the soil CO2 flux chamber. Much of the system is automated and does not require more than one user also. This equipment also does not require the user to have deeper understanding of soil science, so it is not the best tool for teaching foundational soil science topics. The equipment is better suited for a research laboratory setting. The system, however, is reliable. Soil respiration accuracy is reliant on many factors, and the LiCor ensures that consistent and accurate results are achieved each time. With over 20 years of experience, the LiCor Group has created a product that mitigates these factors. The thoughtful engineering of the smart chamber and automated capability ensures that human-induced error is negligible, leading to the most accurate results possible.